frustrated, probably at me, but don't get mad at me. I'm here to help you. So if you don't know what's going on, just come see me. I'm here in the morning, I'm here after school, come during your other classes. Everyone's welcome, all right? And I'll help you. So just know you're going to be frustrated, probably. And just know we'll get through it, and then life will go on, all right? Just have a positive mindset, and just know you're not going to be alone when you're lost. But at some point, it will click, and it will make sense. It might just take a while. These first few sections, I'm sorry, there's a lot of writing. It's not even going to feel like math. Like you're going to be writing a lot. It's more like an English kind of lesson for the next couple weeks, okay? This first one is on inductive reasoning and conjectures. It's exciting stuff. Let's just see, what is inductive reasoning? All inductive reasoning is making decisions based off of observations and patterns. So you're going to be given an example, you're going to notice something about it, and then you're going to say a conclusion based off of it. So based off of observations and patterns. A conjecture, you've used this before, is just an educated guess. So this is kind of what your conclusion is. It's an educated guess about something. So that's why we use that inductive reasoning, is to make this educated guess. What the correct term is, a conjecture. Yes, sir. Oh, did they? What did they say that you could? So you went on an airplane, and we were wondering if they would take us compass or not.
Yeah, they were like, we can't really take this on there. Can we use some weapon? Alright.
That's fine. Good to know.
Yeah, so I'll take some.
Okay, good to know. Funny.
Where'd you go?
Minneapolis.
Boy, that's a far. That's a
It's like a 45-minute flight.
It's the best flight ever. Because your plane's super tiny.
Yes.
Yeah.
I couldn't stand up all the way.
Oh, seriously?
Yeah.
How funny. Okay, let's make some educated guesses based on this pattern. And then we're going to find the next term. So what's happening from each number?
Going down.
Yep, we're just subtracting 7 each time. So my next number would be 10. And our conjecture, so what's our conclusion? Subtract 7. That's it.
So it's like a pattern.
Yeah, that's it. Today's all about patterns.
How's that funny? It was my observation.
And you're not wrong. You are so right. You're so right. Okay, what about this one? February, May, August.
Oh, September.
How many months between February and May? March, April, May. 3. May, June, July, August.
Oh, I got it. December.
September, October,
Oh, November. I got it.
November.
Oh, so you.
So every third month, you could say?
Also the pattern.
Yes. Every. Not ever. Every. Okay, we're going to do the same thing, but now we're going to bring in, like, geometry and some more math, okay? So same thing, we're just making an educated guess. The sum, what does sum mean?
Addition.
Addition.
To add. So to add 2 odd numbers together, what do we get? Yeah, so it would result in an even number.
Even?
Yep, I'm going to put results in an even. So they gave us a statement, and we just made a guess about it. Okay? What's the next one? Okay, you try the next one, then I'll catch up. The product of 2 even numbers. Write it down. Don't say it. Think about it. See what you think.
Can I get a drink?
Yeah, you sure can. The product of two even numbers. Results in a what? Where'd you guys put? Yeah. If you multiply any two even numbers together, you're going to get out a even number. Okay, the next one's some geometry. So we have 3 different segments here. It says the relationship between segment AB and EF. That's what we're trying to make a guess about. So if AB is equal to CD and CD is equal to EF, what can we conclude?
AB is equal to EF.
Yeah.
Thanks.
So if you're lost, I'm just going to draw a quick picture. Here's AB, and I'm going to say it's 5. Here's EF. If AB is equal to EF, what does EF have to be? 5. And then I have CD. And if CD is equal to EF, what does this have to be? So now what can I conclude about these two?
They're equal.
They're equal. Perfect. Do it again. I've been so off today. Thank you. EF.
Oh, there we go.
My fault. I get it wrong up
I
there.
said the answer, and I still got it wrong.
I did it wrong. That's why. Being a bad teacher.
What am I filming?
It was my fault. It's my fault. Okay. A counter example is just something that proves a conjecture to be false. So we're going to be given now a statement, and our job is to see if we can think of something that makes it false. That would be a counter example. So the sum of 2 consecutive integers is always odd. So consecutive means next to each other. So if I said 9, you would say like 10. If I said 22, you would say 23. They're next to each other. So if I add 2 of those numbers together, what would my result always be? Yeah, an odd number. So is this true? Yeah, this is true. An even plus an odd number is always going to give you an odd number back.
It's like integers.
An integer is just a whole number, positive or negative. Words are hard. Words are hard. Okay. If the area of a rectangle is 6 square inches, then the dimensions must be 2 by 3. How do you find the area of a rectangle? Length times width, right? 2 times 3, that does give me 6. But, is there a different way to get to 6 when I multiply?
Yeah.
What? 6 and 1. So that would be our counter example. So we could say false could be 6 inch by 1 inch. We gave a counter example, so it's false. If JK equals KL, then K is the midpoint of segment JL. Is that true all the time, or can we think of something where it wouldn't be true? So you kind of think outside the box. If I have segment JK and segment KL, I know they're equal, does that make K the midpoint? No? Yeah, they could be 2 different lines. So an example, so we're going to write false. What if we have an isosceles triangle where those lengths are the same? Is KL still the same as JK?
Yeah.
Is K the midpoint? Are they on the same line? No. Are these 3 points on the same line? No. So it's K would only be the midpoint if it's on a line. So K would just be. It would be a vertex. Vertice. Close. These are vertices. But so that'd be false because we gave an example where it wasn't the midpoint. Okay, you read the next and just see if you can think of it. If ABC is equal to angle DBE, then angle ABC and angle DBE are vertical angles. Can you think of a counterexample to where they wouldn't be vertical angles? Vertical angles are these ones. Like when those angles are equal. Those are vertical. Is that the only time we have congruent angles? That's what you're thinking right now. Or should be thinking. What do you think, true or false?
False.
He says false. Does anyone agree?
I don't know.
I just got kicked out again.
You can hang out here. I will. Okay, it's false because let's say I have angle A, B, C. And let's say this measures, I don't know, 60 degrees. And then I have angle over here, DBE.
Happy birthday.
Are those vertical angles? No, but are they still congruent? So it's false. You gave an counterexample to prove it not to be true.
So it's like the 180 stuff, and
No, it's
like the
proofs.
we have to like write the
This is our introduction to proofs.
Can I click the arrow?
It is, yeah, you can go arrow.
Ooh,
Homework! Yeah, proofs aren't fun for you guys. That's how you learn them.
next year is it like the wait? Is this like the tan?
Yeah.
Oh, I